Okay, so we are looking at this example here. We need to find the I, we need to find the Y, and we need to find ZE. Once you find them, it's easy to find the stress, because bending moment you can solve using the beam. Then it's easy even to find the Young modulus. Okay, the section modulus you can solve as well. Now this is the member we have. How do we proceed from here? How do we proceed from here? So we have got AB. The first thing we need to do is to find where is the central position of this member. In this direction, this is the Y direction. Then we have got the X. So vertical is Y, then horizontal is XX. We want to know from here what is our Y from the bottom. In some books, when we solve, we say Y bar. Like when we are dealing with the strength of materials, we call it Y bar. In structural construction, you just say Y. Y is measured from XX axis to the base. This XX and YY, where they cross here, this is known as neutral position. This is where it is centrally concentrated in terms of the weight. So it is neutral position. When you put a point there, it means it's balanced. So we measure YY from there. If we want to calculate X bar, we go this way, X bar. But because it is symmetrical, it is equally shaped in terms of the vertical direction, vertical layout. Therefore, the X bar is right in the middle of the size 150. So the only challenge is for us to solve Y bar. How do we go about it? This is the story. So what you do, you split that member. It's not that they are separated, but just for the sake of mathematics, that member and that member. Then you have got the neutral position. Then you have your Y bar. This is the A, B. So we have AB. So we have like demarcated this based on the direction of our solving. Now, when you look at this member, it has got its central position there. That's its center there. From the base. And also this member has its central position. I don't want the Y bar. Let me just take it that this is the central position of this one. This is I'll call it, this is the Y1, Y2. And also this one has its central position Y3. Now, when you draw this, when you draw all these, they are coming from the center of the member. If you draw like a cross section, which I don't like, it just increases workload. Just know to say, this is the center of this member, and this is the center of this member, and this is the center of this member. Now, what we do, we are just solving, we are looking for the y bar. Y bar is situated at an unknown point. Y bar. That's where it is situated. So we say, this I'll call 1, 2, 3. So area total times y bar is equal to area 1 times y1 plus area 2 times y2 plus area 3 times y3. This is how you tabulate them. Now, the areas of all these. So the area of 3 is equal to 150 times 15. Just this. 150 times 15. Area of this one, area 2, is equal to, it is equal to 10, this is 10, 10 times 80. The height times breadth. Then area 1 is equal to 60 times 20 in short. Yeah, so breadth times height. So this is what we have. Now, when we say total area, what is the answer here? When we punch, we'll say 150 times 15 is 250. 15 times 5, 75. We write 5. The 0 is already there. 15 times 1, 15 plus 7, 22. Oh, I'm good. Then this one is 800. This one is 1200. So you add the total area. Area total is equal to 2250 plus 800 plus 1200. So this and this gives you 2000. So your answer is 4250 total. So you come 4250 y bar is equal to A1 is 12 times the half of 20, because it's half height, is 10 plus area 2 is 800 times the height of this one from B. Everything must be from the base. So first height, half of the 80 is 40. 40 plus 20, 60. So you write 60 here. Don't write 40. Plus area 1 is 2250 times the height, half of 15 is 7.5. Plus 80, it's 87.5. Plus 20, 107.5. 107.5. Then you say y bar is equal to this answer. Okay, I don't have a calculator. Plus 00048 plus, okay, this one I'll look for a punch. Plus 48000 plus that number 2250. Why don't I kill this line? Times 10. 7.5. This one is wrong. Then you divide by 4250. What is our Y bar? This is when you are looking for the centroid. Centroid. What is our Y bar? So we say, I'm just looking for a calculator, you know. I also used calculator. So we say this one plus that one is giving us 6,000. But it's this guy here. So we have got 225. Okay. This is the only time I can even confirm times the times in 107.5 equals, hey, is this true? Okay. Plus 6,000 equals, divide by 4250 . Oh, 58.32. 58.32 millimeters. So that is that is from the bottom. When we measure from the bottom. Now when we measure from the top, we can say this one plus that one subtract that. You can also measure from the top. So if we say minus 115, 115, then it gives you the number on top. There. So our Y bar is 58.32. That is our Y bar. Okay. But that's the approach when you want to find the centroid. So the area of this from there, the area of this from there, the area of that from there. The total area times Y bar, then you solve in this manner. That is how you come up with your Y bar. Okay, so after that, the next part we will need to look at is how do we find I. You can only find I after you have found Y bar. Then ZE is easy because it's the I divided by Y bar. Okay, thank you.